what closest we have just found is the flags are basically indicators as well as symbols, or maybe a high priority task. All right, that high priority stuff we'll discuss later. So first is they are basically an indicator. So what they indicate actually? What they indicate. So if there's a territory and that territory is having its own particular flag, like we are Indians, we have our own flag, and we hoist it on two occasions generally, Independence Day and the Republic Day. Finally, so what does that means? What does that flag will somehow indicating something that this particular region belongs to this flag owners. So whatever territory we are having, so it's from like if this is a roughly made figure of India, so this flag belongs to this territory. So this means that this whole boundary condition they comes under this flag, the flag that belongs to India. Fine. Outside it, there are many. This side we have Pakistan, above we have Afghanistan, this side we have Nepal, then above Nepal we have China. So every country has its own flag that indicates that no other country can interfere. Fine, we all have our own indicators. They indicate that this area belongs to someone else. Okay, it's the same thing applies here. Flag means an indicator or a condition or a symbol, definitely. Fine. So when we come to the technology or this processing stuff, in 8086, so whatever you are watching on the screen right now is called the flag register. This is a 16-bit register. Fine. But not 16, all the 16 bits filled with the content. There are few bits which are left for some purpose, but they were not filled due to recent advancement in the technology or overlap in the technology. Fine. So let's start one by one from left side. This particular side, it is right side. Okay. So let's start one by one. CF. Are you all getting it? CF. CF stands for carry flag. Fine. So before we start with the flags, there are few things we use with flags. When flags are 1, there is one value in all of the bits which are located in this register. If there is 1 inside any flag, they are called set. The particular flag will be called set. And when it is having 0 value, then it will be called not set. Okay. Never say reset. Reset is a process. Not set is a state. Set is a state. So when flag is having 1 value, you will call it set. When it is having 0 value, you will say not set. Same is the case with carry flag. If carry is having 1, that means carry flag is set. If it is 0, carry flag is not set. This is the technological statements we'll be using. A flag is set, that means flag is 1. If it is not set, then it is 0. All right. So first flag what we are having here is the carry flag. Fine. In total, how many flags we are having? Second is PF. then AF, then ZF, then SF, TF, IF, DF and OF. Fine. So let's start with the carry flag. What is the meaning of carry flag? How many of you have ever attempted these kind of questions when, let's say, okay, tell me what will be the answer of this particular question? What will be the answer of this? Quick, quick. What will be the answer of this? Anyone? Is this Boolean expression visible or not?
Yes, sir.
So is it really tough to solve?
Sir, 1 carry 111011010.
All right. Anyone else? Okay, let me do it. Otherwise, it will take a lot of time. 000 011 0 1 0 1 1, then 1 plus 1 0, and there is one outside. That what will people call? This is called carry. Fine. This is what we call carry. So this total result comprises of how many bits? Two 8-bit numbers as inputs, and the result is coming out of how many inputs? What is the size of the result? How many inputs are coming out in the result? Tell me. Result कितने bit का है? Is it 8-bit or is it more than 8-bit?
9 bits.
9-bit तो है. But where this 9th bit will go if you are not including this in the answer? If you are not including it here, where this 9th bit will go? डिजिटल इलेक्ट्रॉनिक्स में जब कैरी फ्लैग आता है तो कैरी फ्लैग उसके बाद जाता कहाँ है? When you are having a carry out of any calculation, where it goes? Is there any place? Have you studied any place where this carry will go? All right, let me tell you then. This 9th bit which is coming out as a result, and it is part of the result because we can't avoid the carry part. So this is the place where this carry will be stored. The place is called your carry flag. So whenever carry comes out of any operation, it will simply be redirected to the carry flag. Okay, so that 9th bit or the 17th bit or the 33rd bit which is coming out as a carry, it will be simply stored in the carry flag. That's it, nothing else. Fine, so you just have to be curious about every bit. The moment you are doing any calculation, no single bit will be spared. Every bit is important to us. Okay, so whatever the carry coming out of any operation, that simply will store itself into the carry flag. Clear? Is that clear, all of you?
Yes, sir.
All right, next we have is PF. P stands for parity. P stands for parity. Fine. And what do we know about parity? Anyone?
The extra bit we send with the code.
The extra bit. Okay, you mean that parity bit? No. That parity bit is different. And parity flag is different. That parity bit has a different phenomena. Fine. And that parity flag has a different phenomena. Parity bit is mostly utilized in communication. The parity is simply, we just need not to think too much about anything. It comes from the base or the root of this word is pair. Fine. So we just need to take care of the significant bit. What is the significant bit in the binary? The significant bit is 1. Fine. So we just need to see how pairs are being done. How pairs are being created of 1. If there are pairs of 1 having even number like 2, 4, 6, fine, then the parity is even parity. 1. Fine. If the number of pairs are not even, they are irregular, then parity is simply odd. Okay, so it simply gives you the number of times 1 is getting repeated in the bit pattern or the set of data. So parity is simply related with the pairs which are having 1. Okay, so if even number of pairs, the parity flag will become 1. That means it will be set. If it is odd, it will be not set. This is the parity flag. That's it, nothing else. Is it clear? Is that clear?
Yes,
Yes,
sir.
sir.
All right. So next we have is auxiliary carry. AF stands for auxiliary carry. Auxiliary carry is little confusing because it is only associated with the movement. Movement of what? If I tell you in terms of digits, wait, you can write in terms of digits as well. This is D0, this is D1, D2, D3, and this is D4. So what happens in the case of auxiliary carry when there is a 1 in D3? That is your D3. It is having a 1. Fine. Then this 1 moves from D3 to D4. And where is D4? D4 is auxiliary carry flag, auxiliary carry. So it only represents the movement of 1 from D3 to D4. That's it, nothing else. There is no complicated operation of auxiliary carry flag. It only indicates 1. It will only become 1 when D3 is already having a 1 and there is a movement of 1 from D3 to D4. From D3 to D4. Alright. So auxiliary carrier is just that simple. There's nothing complicated about, like we are having an addition operation here in the carry flag or counting the number of ones in the data. No, it's not very detailed. It's just like this. Fine. So come to the next flag. Next flag we have is 0. ZF. ZF stands for 0 flag. Now what kind of flag it is which gives me only the 0 value? Right? What kind of flag it is which gives me the 0 value? Now there is something very confusing about this 0 flag. Whatever I say, now write them very carefully. Write them very carefully. Somebody is having the mic turned on. Kindly mute yourself, because 0 flag is very important to understand. Because the language is very typical. It's having very typical language. So what typical thing we are having here is the way we are saying it. Fine. I told you the conditions are very set. When 0 flag is 1, it is called set. When 0 flag is 0, it will be called not set. Fine. So just need to take care of few things. What happens is when zero flag will become 1 and when zero flag will become 0. This is the confusing part. When zero flag holds a value 1, that means zero flag is called set. When zero flag is having 0, that means zero flag is not set. Fine. But the problem is when zero flag will become set or not set. When this kind of condition will come. See, I've already given you the rule of the programming in assembly language programming. The rule number 2 says whatever the result is coming out of ALU, it will be stored in the accumulator. Fine. So what zero flag will check, it will simply check the accumulator. Fine. What is inside accumulator? If, now listen to it very carefully. If accumulator is having a zero value, something happens and in the operation, the accumulator is having the zero value. Fine. This is the case when zero flag will become 1 and will be called set. I repeat, in any operation, the output of the ALU, it is getting stored in accumulator and zero flag will check accumulator. If the accumulator is having a zero value, then it is called zero flag. It will be raised, zero flag raised ho jayega, it will become high, then we'll call it zero flag is set. Vice versa, after checking register A, if it is not equal to 0, it is having some value, then this condition is true, that zero flag is 0, it is not set. That means the complicated part is that zero flag only gives us the condition, this one. It is more interested when accumulator is having this zero value inside. Fine. But when it is not having any zero value inside, this thing goes like this. Is that clear? Zero flag? Is that clear? Zero flag? Or do you want me to
Yes.
repeat? Just
Sir, repeat once again.
repeat already means once again. Just it's like say repeat. So zero flag is actually associated with the accumulator. Fine. Accumulator stores all the outputs coming out of ALU. Okay. So whenever ALU process two numbers, let's say A and B, and something happens, and the result comes out of a register A is 0. In that case, what will happen? Zero flag will become high. It will raise itself because accumulator के अंदर जो value है वो zero है. इतना समझो. Whenever accumulator is having zero, तो हमें कोई indicate कराने के लिए चाहिए ना कि accumulator के अंदर zero आ गया. So this is that indicator which tells us that accumulator is right now having the zero value, zero flag. So how it will be indicating? It will turn itself to 1, which shows zero flag set हो गया. That means accumulator के अंदर value क्या है? 0 है, which comes as output from the ALB. Is that clear now?
Yes, sir.
And vice versa, if value is non-zero, that means zero flag is not set. ठीक है, इसमें बस कंफ्यूजन यहीं पे होता है. जीरो फ्लैग इज इक्वल टू 0 0 0 0 एंड जीरो फ्लैग इज इक्वल टू 1 सेट. तो इसको अपना एनालॉजी बिल्कुल क्लियर रखो, सिर्फ एक रखो. जीरो फ्लैग 1 दैट्स सेट, opposite to it 0 not set, that's it. Okay, clear now? So this was your zero flag. Now what we have is this SF. SF stands for sign flag. SF stands for, I'm writing it in the bottom. SF stands for sign flag. Fine. So how do we know about signs? Signs. How many signs are there in the operational numbers or booleans? How many kind of signs do we know? Or data is basically of how many types? It is basically related with the type of data. So how many types of signs are associated with the data? Okay, you must not be getting what I'm trying to ask is, basically there are only two things with a sign, or there are basically two types of data. Fine. First is called unsigned and second is called signed. You must be getting what I'm trying to tell you right now. Signed and unsigned. Getting my point? Are you getting my point? Is there any other category? Although there will be subcategories, I agree, there will be subcategories, but on a number line of data, there are only two type of data. Either it is signed form or in the unsigned form. Sometimes you call it in the mathematics, if there is a sign, that means negative associated with a number, then it is called a signed number. Definitely, when there is a sign associated with any number, it is called signed number. In computer or in computation, we call a negative number as a signed number, not a negative number, not like -3. It is a signed 3. 3 with a sign. Fine. So if there is a number which is having a sign associated with this, okay, and how we are going to know about this in the binary? Because we are dealing with what? We are dealing with the machine. Machine understands only 0101. All right, but 0101 will not be able to tell me which number is signed or which number is unsigned. So how do we take care of signed numbers in digital electronics? How do we take care of signed number in digital electronics? कोई बताएगा मेरे को? There is a particular bit. There is a particular bit which is responsible for the sign bit. Which bit was sign bit? Anyone? In digital electronics, which bit was sign bit? All right, you may not be getting it. In an 8-bit data, if the data is of 8-bit, your 8th bit, D0, D1, D2, D3, D4, D5, D6 and D7. This 8th bit tells us the sign data. If and how it shows, if D7 is equal to 1, that means the number is a signed number. If D7 is equal to 0, that means the number is unsigned. Fine, same is the case, same is the location you can see over here. If I keep writing after D4 in the flag register, it is D5, it is D6 and this is D7. Except the sign flag is your D7, same. We took the same location in order to identify the sign. Fine. So whenever there is a 1 at D7, that data will be your signed data, and this is 0, then it will be an unsigned. Fine. That's why we even kept it at the location of D7 so that it is easy to copy and paste and check. Is that clear? Sign flag? Is that clear? Sign flag?
Yes, sir.
Yes, sir.
Okay, so what is the time now? 11:03. Okay, seems like I may not be able to cover it today because next 4 flags are very important, and these are the actual flags of 8086. Till this point, what we have studied is these are the flags coming from 8085 microprocessor. Same flags we were having in 8085 as well. Fine, but the actual flags we are having here in 8086, which actually shows its power, how much powerful it is, how much more intense in this. These are the next fours. Fine. So in total, there are 9 flags in the 8086 microprocessor flag register. And trust me, this particular topic is of more than 10 to 15 marks. This particular register, they can straightforward ask you draw and explain the flag register of 8086. They can be used anywhere. They will be used everywhere in the programming. Flags will be everywhere in this subject. So just put your attention maximum whenever we are talking about flags, like today and the next class also. Okay, so we'll finish it in the next class. Next 4 flags. Okay, till the time, if there is any query anyone wants to ask, you can ask. Anything?